Welcome to our video on hydroelectric energy. In this video, we will be discussing the basics of how hydroelectric energy is generated, its advantages and disadvantages, and its future. Whether you are a student or just curious about hydroelectric energy, this video will provide you with a comprehensive overview of this important energy source. Let's get started. Hydroelectric energy is a clean and renewable energy source that is produced by harnessing the power of moving water. It is one of the oldest forms of electricity generation, and it continues to be a significant source of energy today, providing approximately 10% of the world's electricity. In this essay, we will examine the process of producing and storing hydroelectric energy. Hydroelectric energy is produced by converting the kinetic energy of moving water into electrical energy. This is achieved by building a dam across a river or a waterfall to create a reservoir of water. The water is then released from the reservoir through a turbine, which is connected to a generator. As the water flows through the turbine, it causes the blades to spin, which in turn generates electricity. There are two main types of hydroelectric power plants: impoundment and run-of-the-river. Impoundment power plants are typically large facilities that use a dam to create a reservoir. Run-of-the-river power plants, on the other hand, do not use a dam but instead rely on the natural flow of water through a river. Both types of power plants generate electricity in the same way, but the size and capacity of the facility, as well as the amount of electricity generated, can vary significantly. Once the electricity is generated, it must be stored and distributed to customers. One way to store hydroelectric energy is to use pumped storage hydroelectricity. In this process, water is pumped from a lower elevation to a higher elevation during periods of low electricity demand, and then released back to the lower elevation to generate electricity during periods of high demand. This method of storage allows hydroelectric power plants to quickly respond to changes in electricity demand, making it a valuable tool for grid stability and reliability. Another way to store hydroelectric energy is through the use of batteries. By storing excess energy generated by the power plant, batteries provide a reliable source of energy during periods of low water flow, such as during a drought. Batteries also allow power plants to store excess energy generated during periods of high water flow, which can then be used during periods of low water flow. The majority of hydroelectric power plants are located near large bodies of water, such as rivers, lakes, and oceans. This is because the kinetic energy of moving water is the primary source of energy for hydroelectric power plants. Some of the largest hydroelectric power plants in the world are located in China, Brazil, Canada, and Russia. In China, the Three Gorges Dam on the Yangtze River is the largest hydroelectric power plant in the world, with a capacity of over 22,500 megawatts. In Brazil, the Itaipu Dam on the Parana River is the second largest hydroelectric power plant, with a capacity of over 14,000 megawatts. Canada is also home to several large hydroelectric power plants, including the Churchill Falls Generating Station in Labrador and the Robert Bourassa Dam in Quebec. In Russia, the Krasnoyarsk Dam on the Yenisei River is the largest hydroelectric power plant, with a capacity of over 6,000 megawatts. Other countries with significant hydroelectric power capacity include India, the United States, France, and Norway. Overall, hydroelectric power plants are located in countries with abundant water resources and a need for clean and renewable energy. With increasing global demand for clean energy, it is likely that more hydroelectric power plants will be built in the future, providing a reliable source of clean and renewable energy to communities around the world. Thanks for watching. Don't forget to like, comment, and subscribe for more videos like this one. See you in the next one.